Hi everybody, this is Patrick from 8-Bit Doodads with the first part in a new series, this one covering the Corvus OmniNet or OmniDrive networking system that Corvus developed. Was very popular with Apple IIs and later branched out into some other systems as well. There was a previous quick look video on this, and if you haven't seen that, you might want to stop and take a look at that short video and then come back here and watch this longer edition as we dive in to the actual workings of the Corvus OmniNet.
Say, kids, what time is it?
It's 8-Bit Doodads time!
Now, I just wanted to briefly show you my setup at home so you can see how it normally would be laid out in, say, a classroom or what have you. I have a couple Apple IIs here. This is an Apple IIe. This is an Apple IIgs. And you can see over here, we have our Corvus OmniDrive. Inside there is a 20 megabyte MFM hard drive. We're going to be talking about that as we explore this. And I just want you to see that I can actually log on to the screen and you see the drive lights going and it's loading, in this case, Apple Pascal, which is UCSD Pascal derivative. And there we go. It's booted right off the hard drive. One of the nice things about the Corvus systems is you can actually boot multiple different operating systems just by changing your logins. I'm going to stop here, and we're actually going to reposition this stuff up over on my other bench that we normally work on, because videotaping the monitor from a camera, it's probably a little bit fuzzy and unreadable, and we do have video capture devices. So I'm going to set that up, and also so I can pull this out so we can open up the insides of these boxes for parts of this series. Okay, I've reset up my cameras on the bench, and I thought before getting started, I wanted to sort of lay out what the plan is that we're going to be following to examine Corvus networks and enhance the one I have here at home. In fact, you'll see here, there's 3 Corvus drives. This is not the one you saw a moment ago. These are actually 3 more that I want to restore, and that's going to be part of this project. The one that you saw me booting from is the only one I have, quote, working. And by working, I mean it has a MFM hard drive in it. It's got the Constellation software. That's what Corvus calls their networking software. And the Constellation software is installed and is running and working with the Apple II. On these 3 here, one of them has a hard drive installed, but it won't boot from it. And the other 2 are empty, and some of them are missing parts or what have you, and I haven't verified the status of the board. So one of our projects, or sub-projects you might say, is I want to verify that the drive boards, the server boards that are at the top of this that I showed you in the quick look video, are working on all 3 of these. And the best way to do that is we'll do a step where we swap out the drive boards to the working known unit and make sure that those boards work. And then we can identify if one of them is a failure. I'd be happy if at the end we had 3 working ones. And the reason for that is, as I said, the only hard drive I have working is in the one you saw earlier. I actually have a stack of MFM hard drives, and I've tried to get them to work and boot in here, but I don't know if it's the board or the drive not working. And some of you may realize MFM hard drives are really old at this point. They're almost hitting 40 years, and their failure rate after that period of time is extreme. And that's why one of our other sub-projects, you're going to see 2 things here, this and this. These are both MFM hard drive emulators. This is called the DREM. This one, oddly, is on a website called PDP-8 Online, and it's because it was somebody who was restoring PDPs, and they had MFM hard drives in it, and he made an emulator. So this will emulate a MFM hard drive as well as this. They're slightly different. This will emulate both a hard drive and a floppy drive. So this would be perfect for throwing into a, say, vintage PC or AT that has, standard floppy and hard drives. It has the connectors for doing both of those. They do similar things, although the feature set can be a little bit different. For instance, this one has a VGA port and a PS2 mouse keyboard port. So on this one, you can plug in a monitor and look at what it's doing and change some of the configuration. This one actually uses a Beagle board, which is a more powerful version of something like a Raspberry Pi. This was a little bit higher end, and it uses the Beagle board to do the main logic work on here. And the Beagle board has an Ethernet connector, so you could actually telnet into this to control it or look at how it was running, look at the logs, which would be the same thing as plugging the monitor and keyboard in here. The other unique thing about this one over this one is that it can not only emulate a hard drive. You notice there's connectors here for plugging into something, but then there's also these connectors. And you need to realize this is what the hard drive, an MFM hard drive, would have. So if you're using these connectors and plugging into the motherboard on the Corvus, you're emulating a hard drive. If you're using these connectors, think of it this way, you're plugging in like that, this board can actually read from an MFM hard drive. And so one of the great capabilities of this particular board is to read from an existing hard drive and take all its information off and put it onto the memory card and then use that as your emulation base. So basically to help you convert from a working hard drive that may soon fail into an emulated hard drive. And in fact, that's on the one machine we have with the 20 meg working hard drive. I want to try to copy that off and use it on one of these, and then be able to place this into a machine and have it run that same copy of the operating system, removing the hard drive. So that's one of our projects. One of our other projects, and one of the topics we're going to talk about, is the actual physical network. This is what the trunk cable for the Corvus network looks like. If you looked at my quick look video, I talked about these 3-pin wire, and that's where this would plug into. But you don't plug in directly like this. You actually have 6-foot tap cables that come and join this in T's. And I'm going to go into how we do that in one of the segments of this video, or in one of the parts of this video. Right now, I only have that one Apple IIe wired, and it's actually wired directly from it to the Corvus OmniDrive. So we're going to look at expanding the network so we can extend to connecting multiple drives and multiple machines. So that's one of our other projects on here. That's why I brought out the transporter card. So I'd like to get anywhere from 2 to 4 Apple IIs connected. I also have this, a friend of mine, Steve, who is, I call him the Corvus God, made for me. This is the replacement chip that goes on here. One of the things is these cards, when they were originally made, is for the Apple IIe, and they work in the Apple II Plus. But when the Apple II GS came out, it worked faster at 3.5 megahertz instead of 1 hertz. But the software and the ROMs and everything on these cards are timing dependent, that they expect to be running in a 1 megahertz machine. Somebody came up with a patched ROM that slows the card down or slows the machine down anytime the card's working, or changes the calculation logic so that this card can work in a GS. So I want to try that out. Last thing is, I also received these, and I'm hoping we can figure out how to make them work. I have a couple IBM PC cards that work for the OmniNet, and if we can figure out how to, they're supposed to be software. I may have it. We're not sure. I've got the files. I'd like to see if we can get an IBM PC on the network, and then we'll be able to possibly share data, but also just share the hard drive in this amongst not only multiple Apples, but multiple different types of PCs. So that's kind of the agenda that we're going to be following through. Next part, I'm going to do a little bit of demo so you can see just an Apple II working with this on a clearer screen. And then we'll get to work talking about physical networking, installing the software, and completing each of these projects. Okay, I've broken out one of my Apple IIes. There was actually a mass storage device in here, a CFFA card. I pulled it out and put a Corvus transporter, is what they call their network interface. You can see here, this is the cable. You'd usually route it around the back. They use something called drop cables. I'll talk more about the networking. Right now I have this directly wired from here to the Corvus OmniDrive. I had placed it up here, but I decided to put it down on the ground because it makes a lot of noise. It's got a 35-year-old MFM hard drive in it, and there's definitely a constant whine if it's sitting near you. I just wanted to show you the system from a user's perspective or administrator's perspective of how one would normally operate with a OmniDrive or OmniNet on an OmniNet network. The whole design behind it is to allow multiple machines to access parts of the hard drive, either shared parts or personal areas. And as you can see, when you first turn on your machine, it boots up to the Corvus login menu. One of the things I'm going to reboot again, and I want you to see what it's booting from slot 7, and you'll see a bunch of dots going across. What's happening here is this login program is being downloaded from the Corvus OmniDrive. These drives are actually quite stupid. They don't know anything about files. They actually don't know anything about volumes or directories or users or any of that. It's not doing any of that logic. It just knows how to read or write a block of data from the disk. And I think what's happening is all that control logic for deciding, looking up a username, matching passwords, etc., is actually happening on the Apple here. The Apple and the transporter card just have enough information to grab the boot blocks off of the hard drive and load this login program and provide that to the user. And once you log in, the program then has enough sense to know how to mount the volumes onto this machine, or actually tell the transporter the blocks from 50 to 500 is the volume you want to deal with, and it's just dealing with that data on a block-to-block level. The drive itself has no concept of what operating system I'm running, and it's really up to the Apple to using the 6502 in it to process and do all the logic moves to decide what part of the disk I want to read and write from. I'm going to go ahead and log into the management system. Now, This is running Constellation 3. Which was their third gen. I don't know if there was ever a fourth. There definitely was a first and second gen. The first gen could handle DOS 3.3, Apple II CP/M, specifically the Microsoft soft card, and it could handle the UCSD-P system licensed by Apple and called Apple Pascal. Those are the three operating systems it could run. And in fact, this management program that you see on the screen, the original version of this was written in Apple Pascal. And in fact, all of the utilities on the first two versions of the Constellation software, that's what they call their network operating system, were written in Apple Pascal. They've since updated it in Constellation 3, or they've rewritten it, and it's now written and hosted under ProDOS. So I'll bring up the network utility. It's going out now and it's searching the network and asking, okay, how many OmniDrives are out there? And you'll see it found one because there's only one thing plugged in at the other end of this cable. And this prompts us for a disk password. They do that. This is their only security. I mean, obviously you had to log in to download the utilities. But if you think about it, someone could, those programs that were being run, I could copy them off onto a floppy, boot the floppy on the network, and I'd be able to run those utilities. So they give you the ability to have a server password and a drive password to protect the disk a little bit. Here you can see it deals with volumes, which are the sections of the disk mapped and utilized by different operating systems, and it deals with accounts or users. You can have one volume, and I'll go ahead and tell it to list the volumes. You can have one volume shared by multiple users, and typically you would do this to put your applications. Like say under Apple ProDOS, you'd put Apple Writer or AppleWorks stored on that volume, and you'd actually set it to be read-only and allow multiple users to boot from and load ProDOS on those applications. But then you might give them a separate volume that only they had access to and they could read and write to. And that's where they could store their documents. As you can see, we have a bunch of volumes on this machine. And if you look over at the owner, every volume is typically owned by somebody. And that would be the person who has read and write access to it. But these could be shared by multiple users, and that would go into the accounts and give those people access. If you look in the list, you'll see that there are Pascal volumes, DOS 3.3, and ProDOS volumes. And just to show you a little bit about how we're running ProDOS now, that you could quickly and easily switch operating systems, we can simply reboot the machine. And it's loading the login program again. And now we'll put in Apple DOS 3.3 and our password. And now instead of loading ProDOS, it's booting DOS 3.3. That was the earlier operating system for the Apple. And in fact, I believe there's a feature in DOS 3.3 that I don't think anyone else ever used but Corvus, and I suspect Corvus got Apple to put it in for them. And that is, in DOS 3.3, it had no concept of mass storage, and because mass storage wasn't readily available either. The one exception was Corvus was one of the leading manufacturers and sellers of hard drive systems for personal computers like the Apple, like Z80 systems. There's even a Corvus drive for the TRS-80 Model 2. I believe there's a limited versions of them, but Atari 800 people had them, etc. They were the guys you went to add mass storage. DOS 3.3 had no concept of a volume or a disk drive. It couldn't handle anything past 400K. And if you had a 5 meg hard drive, that could be a problem. What they did was they added a way to say, in the DOS 3.3 world, you could say, give me a directory or open a file on drive 2, drive 1, slot 4, drive 2. If you could have a machine with 4, 8 floppy drives in it if you wanted to. But for the hard drive, instead of making them different drives, again, DOS 3.3 was hard-coded that it couldn't access anything other than by slot and by drive. So if you've got 7 slots in your machine and 2 drives, the most you could have would be 14 disks, and no disk could be bigger than 400K. So they added a third thing called volume, and you could put a comma V and a number from 1 to 100 or what have you at the end of that, and you could access multiple floppy chunks of 400K by volume number. So you could create a 2 megabyte section of the hard drive for DOS 3.3 and have that divided into 5 400K chunks. And I actually did this for somebody with a Corvus network with Apple IIs. They were running for a point of sale system. And on their point of sale system, they could track as a customer came in, if they were a customer that got billed at the end of the month, they could put in a customer number, and based on that number, you could calculate which volume the customer was on. So we could have thousands of customers by spreading them across all those disks. This was before ProDOS came into play, and it was the only way to, on an Apple II, to be able to store great deals of data. So that was interesting. So that's one of the things with running DOS 3.3. They had this, quote, hack to allow you to have bigger disk drives. Now, just a round out demonstration of being able to load different operating systems, different programs, I'm going to let it boot back to that login. And as you can see, I can type in Pascal, and now it's booting Apple's version of the UCSD P system called Apple Pascal. And here, this is what the P system's interface looks like. Is you get a command line, and you can run a compiler, an editor, the file utilities. So if I wanted to get a directory of the Pascal volume on my drive. Hold on. There we go. And now it's listing out all the Pascal files. And you can see on here all the system programs. Basically, this menu is it. All it will do is then run another program. And in fact, a lot of the letters at the top of the screen for like filer or editor or what have you, turn around and run one of these system programs. So you'll see system filer, there should be system editor, the linker, etc. So that's how Pascal worked, is basically the menu loaded and ran one of these other utilities, which would then actually either allow you to edit your code or compile your Pascal and turn it into P system code, P code, which could be run not only on the Apple, but in theory could be run on any other P system. So we're going to come back to the software later, because I would actually want to step through how you install the software, setting up, creating accounts, creating users. So we'll show you how we can actually create those shared environments. Maybe we'll get to installing Apple Writer or AppleWorks, and we'll set up a couple machines so you can see it running. I thought next we should talk about networking. As you can see here, I have a cable running. This cable is unique. It has, in fact, I'll pull it out. It has 2 of these ends, which is actually a 3-pin, and there are 3 pins on here. At the other end of this cable is just another one of these. If you're if you're setting up your network for the first time, or you're doing some debug work or something, and you just need one Apple and one OmniDrive, you can actually wire them directly into each other. We'll talk a little bit more about how you have an expanded network and setting up the physical network between machines. Okay, this segment's on the physical network of a Corvus OmniNet, which is the network. The OmniDrive is the storage server. They used a trunk cable. They specified Belden 8205. And a part of that specification, if any of you all knows networks, Ethernet and other networks, there's usually a resistance. Is it 75 ohm cable? Is it 50 ohm cable? What have you? In this particular case, it's twisted pair wire, but this specification was how many twists over how many inches and what the resistance of the wire was, and that's where they came up with the 8205, and that's what Corvus specified. They used what they called taps. I'm going to say it was for terminal access point, and you'll see there's little curves in this for the cable to go through. And what you'll see in here, this is in fact, I'll bring it up a little bit closer. There's two metal pieces in here that are vampire taps that the way you would, when you first made this in your lab or in your building and you were networking the things together, what they'd have you do is cut the cable in the center and pull the insulation apart, and then there are two wires in here, and you'd run one wire on that vampire tap and one wire on this vampire tap, and you would put them through here, and that would create the tap, so to speak, on this trunk line. And then what they had are these cables, which plugged into the network card. I showed you that port before. The 3-pin port. There's actually only two wires there's two wires and a ground in that 3-pin port, and they used what was a mono audio connector that plugged into this device, in that little hole, and it would connect up to those two wires. These things were a very specific length, and so they allowed you to do a drop cable off of this network tap that was coming through, and this connected up to the two wires in this cable. That was the first generation, and this is the only one that I knew. The two Corvus networks that I ran had these white cables and did those taps. They later came out with an updated version, and oddly, with RJ45 8-pin connectors. And what those did was allow you to use, but if you look at it, you're not going to be able to see this. If you look in there, this is not actually RJ45. Two of the ports, hold on. Actually, that's not true. One of the ports looks like RJ45. The other two ports have some other wiring connection, and I have some of the cables for this. But they use this as an alternate connecting method. And I think the reason being is instead of having one trunk cable, you could buy cables from them of certain lengths and basically daisy chain, and you wouldn't have to do what I just described, which is break this cable open to get a connect between those. But both networks use the same kind of trunk cable, just with a different connector pin. The other thing you'll see here on me, these are some resistors, 100 ohm resistors. The way their network worked is at each end of the trunk, you needed to put a resistor between the two wires, and that closed off the network. What I have running right now, you saw me booting the PC, is I basically have two of these cables, one plugged into the OmniDrive, one plugged into the PC, using a female-female. If you only have one machine connected up, you don't have to do the resistance. You can basically plug them end to end. And this is one of the ways to do that. You just put a barrel connector on here, plug in another one of the white connectors, and you can point to point between just 2 points, connect them up. There are versions of this for that. I said RJ45. Here's those RJ45 links, and using the standard RJ45 female to female, I can do the same thing. I can connect up 2 machines. So you can do that. That's not what we want to do moving forward. We want to hook up multiple machines. And so what I've come up with, and I actually have sourced for building out my network at home, this is the trunk cable, and we'll run it around the home office here. And here is one of those drop-down cables, the equivalent of this white cable or the gray cable I just showed you. I have the connectors to plug it. I have these 3-pin connectors, and I have the crimping connectors that go on here that allow me to crimp on to the end of this cable. And I have what it's called a vampire tap. In fact, I actually have a package of them, which allows me to connect this cable in on one end and pass a cable, this cable, through, and it vampire taps on those 2 wires that are in here. And I'm going to use this to build out our network. So I can have those same drop cables to each of my apples connected up to the bus. So that's something we're going to do as part of this project. I probably won't record all of the steps of that, but the basic mechanics are, we'll have this cable running around the room. Each machine will get one of these cables with this vampire tap on here that will go on here. And at the 2 ends of this trunk will be these resistors. And that's what makes up a physical OmniNet network. If any of you worked on some of the original Ethernet networks or before Ethernet, there was GNet and what have you. There were other networks that competed before Ethernet really took off. You'll see that a lot of them all had terminators at the end of their networks. That's what this resistor is doing. It's the same kind of thing. A lot of them were these kind of trunk or bus-based networks that tapped individual stations on. In the case of Ethernet and, like I said, GNet, and there were some others, they used BNC connectors to connect from point to point and in the back of the machine. But in their case, you couldn't have a drop cable. They had these BNC connectors that plugged in to the cable on both sides and it had to go right into the machine. So you had to hop right between the machines. OmniNet allowed you to go about 1,000 feet. I think it was 1,000 feet. It might have been 1,000 meters, which was the same as GNet and Ethernet at the time. You could extend it. They had a box, which we would think of at that time frame as a Ethernet repeater, which allowed you to extend a network. They had a box that would allow you to plug one OmniNet into and another OmniNet into. Each were 1,000, and it would repeat the signals between them. For reference, this network existed before AppleTalk. It didn't exist before Ethernet existed, but it existed before Ethernet was popular, especially in the PC world. Also had Ethernet, DEC had Ethernet. The big machines were using Ethernet to move data between each other, but it was not a PC-based standard. And that's why you hear me say something about GNet. That was one of the first networks we had. It was one of the more popular networking cards that worked with Novell NetWare, and it ran at 1.5 megabit. OmniNet ran at 1 megabit, which was not that unheard. That was in range. Starlink from our Starlan from AT&T, its first iteration ran at 1 megabit, and it was designed to run over telephone wires. don't know if the first generation of Ethernet ran at 1 megabit, but later, even the first more commonly available, the first one I touched, ran at 10 megabit. It wasn't that much significantly faster, and not like it is today. But that's kind of the hardware, the network hardware overview of what we're going to do with OmniNet. I'm going to get that set up and get our Apple IIe connected to our device so we can continue on with the next session. Okay, I think I'm going to make this the end of part one, and since we've gone over what it looks like running the network, how we're going to have to wire it up. I think I want to say for the next part, testing out my stack of OmniDrives. As I said, I've got one working that you've seen, and I've got 3 others. And what I'd like to do is take the boards out of all of these. This just mounts here like that. And put them into the one unit with the working drive and known working power supply and everything else. What I'll have to do is make sure I set the various dip switches on here, and just simply replace the boards, boot them up and test. So that's going to be for us next time. In the meantime, I'm going to go ahead and make my physical network that I showed you with the vampire taps so that we can get a couple machines running. So once we can confirm some of these other drives work, we can move on to getting them installed with those MFM emulators and bringing up multiple drives on the network. So I'm going to leave that for part 2. If you have any questions, if you have any comments, something you'd like me to go over during the next part that we'll release probably in about 2 weeks, please leave them in the comments section. If you like this video, hit that thumbs up. And if you haven't already, please subscribe to our channel so that way you'll get notified when new videos come out.